This is the Packaging Podcast with David Holliday, the self-appointed 42nd most visionary marketer. Yeah, right.
I've seen a lot of videos on YouTube and on LinkedIn showing various types of lasers used for adding variable information to products. Many of these videos show the lasers operating with zero protective guarding in place and operators in the area not wearing protective glasses or goggles. This is entirely wrong. When installing laser systems for product coding or for any other application, safety should be the single most important consideration, not something that is ignored. Uncontrolled laser light can cause eye injuries, burns, and even fires. Yes, I'm aware of at least one instance where this has happened. That's why there are rules that need to be followed, like the ones set by ANSI, OSHA, or the FDA. The FDA categorizes lasers into 4 major hazard classes, each with specific safety concerns and control measures. These classes range from Class 1, which is considered non-hazardous under normal operating conditions, up to Class 4, the highest hazard class capable of causing skin and eye injuries from direct and scattered radiation and can also pose these fire hazards. Packaging lasers are usually part of Class 4, and the object of laser safety guarding is to ensure the finished installation complies with Class 1, non-hazardous under general operator conditions. Guarding for CO2 lasers. CO2 lasers emit light with a wavelength of approximately in the area of 9 to 11 microns in the far infrared spectrum, so this light is not visible to us humans. While it can undoubtedly damage eyes or skin with prolonged exposure, CO2 laser light does not penetrate as deeply as light from some other types of laser. Simple perspex, acrylic or plexiglass, is used for guarding CO2 lasers primarily because it is opaque to the specific wavelength range produced by these lasers. Perspex can effectively block the laser radiation, protecting users from potential harm. When used as a shield, Perspex effectively protects against accidental exposure to the laser beam, preventing eye injuries and skin burns, and its transparencies allows operators to see the work process while being protected from laser radiation. Laser manufacturers offer a number of guarding solutions for CO2 lasers, from simple Perspex cones that cover just the marking area up to complete interlocked guarding systems. Guarding for fiber, UV and green lasers. While simple Perspex guarding works well with the light generated by CO2 lasers, it is not suitable for the shorter wavelength light produced by fiber, DPSS, UV and green lasers. This type of laser light passes right through Perspex and similar plastics. In addition, laser light of these wavelengths penetrates into the eyes and into the skin more deeply than CO2 wavelengths, potentially causing more damage, particularly to the eye's retina. Retinal injuries can be more hazardous than corneal injuries, as they can lead to permanent vision loss. Ensuring complete guarding for these types of laser is a critical part of the installation, since no laser light, either directed or reflected, can be allowed to escape from the system. This type of guarding should be used for all fiber, YAG, UV and green laser installations. Stainless steel is often used to make these guards, but care must be taken with the design to prevent laser light from bouncing around inside the guard until it leaves the enclosure. Baffles are often installed in order to prevent this. Note that the guarding also needs to be interlocked to disable the laser if one of the doors is opened. If the interlocks need to be overridden, say for setting up the laser head, it is crucial that the operator and anybody else in the vicinity wears approved laser safety glasses, correct for the wavelength of the light being generated. Thank you for listening to today's podcast on laser safety for coding installations. We hope you found it helpful, and it will assist you in finding a safe working environment for your laser coders. When planning a laser installation, be sure your vendor is aware of the safety requirements and has a plan to ensure compliance with the requirements. You can learn much more about laser safety from the Laser Institute of America website, and I'd recommend you head over there and see how they can help you. LIA can also provide training for you and your staff, a very comprehensive service. Thank you for listening, and we'll see you next time. Take care.